Hello, pre-calculus class. So this is the graphing example for logarithms that we did not get to do in class today. So I'm going to show you two different ways to do it. The first way is just to keep the equation as it is and find your table of values. Before we even get started though, you should remember your transformation rules. Looking at this equation, I already know that it will be moved down 3 and to the left 1. Now remember, logarithm equations have a domain restriction because they normally have a vertical asymptote at x equals 0. But if this has been moved left 1, I know my vertical asymptote will be at x equals -1. I also know that that impacts my domain and that my range for any logarithmic function is all real numbers. Let's graph it first before we actually fill in the domain. So we need to find some values. The first value I'm going to plug in for x is -1. And if I put in -1, I'm saying 2 to what power gets me 0? Well, that doesn't exist. And that coincides with the fact that there's a vertical asymptote at x equals -1. Let's keep going from there. Let's plug in 0. So that means 2 to what power is 1? Well, 0, right? And then we have to subtract 3, so our answer is -3. Let's put in a 1. So if we put in a 1, we get 2 for the argument. So 2 to what power is 2? The answer is 1. We have to subtract 3, and we get -2. Now, I could put a 2 in there, but then I'm going to say 2 to what power is 3? Well, I'm not interested in that. So I think it would be better to do perfect squares. So I'm going to put in a 3 next, because that makes 4 here. So 2 to what power is 4? It's 2. Subtract 3, and you get -1. Maybe the next one I'll put in is a 7. And I'm choosing wisely for my values of x. So 7 makes 8. 2 cubed is 8, so it's 3. Minus 3 is 0. I think I also want to get a fractional value. So watch what happens if I put in a -1/2. So -1/2 plus 1 is 1/2. 2 to what power is 1/2? It's -1. Minus 3 is -4. Now I have some points that I can plot. I'm going to go ahead and put in my vertical asymptote at -1. Then I'm going to plot 0, -3. Okay. I'll plot 1, -2, 3, -1, and then 7, 4, 5, 6, 7 is at 0. And there I can see, I know what I'm looking for. Oh, let's also put in that -1/2 right here, and that is down 4. So I know that there's a vertical asymptote at 1, and then this comes up because the range is all real numbers. So now we can also throw in the domain is x such that x is greater than -1. And that's our graph. On the next slide, I'm going to show you another way to do the same graph. Okay, here's the exact same problem. We, once again, know it's a logarithm. We know it's been moved left 1 and down 3. We know we're looking for a vertical asymptote at -1. So let's just mark that right in there. But I'm new to logarithms, right? Let's just say. And so I have a hard time evaluating by picking x's. So what I'm going to do is I am just going to solve this for x. I'm going to take the equation and I'm going to turn it around so it's x equals. So I'm going to add 3 to both sides. And this is the toughest part of this. Okay. Now I'm going to turn it into an exponential equation. So remember, the base is the base. So this becomes 2 to the y plus 3 power equals x plus 1. We're almost done. We just have to subtract 1 from both sides. So we have the new equation, which is really the same equation. It's just been turned around. X equals 2 to the y plus 3 power minus 1. So I am going to pick y's and solve for x's. And these will be the ordered pairs. So it's much easier to choose the y's and figure out the x's. So why don't we just start with a y of 0? Well, that's easy. 2 cubed is 8 minus 1 is 7. And I'll put in a y of 1. 2 to the 4th is 16 minus 1 is 15. All right, we're getting pretty far to the right there. So let's put in a negative 1. So 2 to the 2, or squared, negative 1 plus 3 is 2. So that's 4 minus 1 is 3. Put in a minus 2. You get 2 to the first power, which is 2 minus 1 is 1. Let's put in negative 3. That's 2 to the 0, which we know is 1. 1 minus 1 is 0. Let's do one more. We're running out of space here. So I'll just do another XY chart here, and we're going to plug in negative 4. So if I plug in negative 4, I get negative 1. 2 to the negative 1 power is 1/2. 1/2 minus 1 is negative 1/2. And these are the same ordered pairs we had before. Some people could just say this is much easier to find it this way. So let's plug this in. We have 7, 0. And then we have 15, 1. I'm not going to plot it. 3, negative 1. 1, negative 2. 0 is negative 3. And we did that other one. Negative 1/2 is negative 4. And there is my graph. And we still know that the domain is x such that x is greater than negative 1. And the range is all real numbers. And there is a vertical asymptote at y equals negative 1. It is your choice, whichever way you want to do it, the way where you turn the equation around into its matching exponential equation, or just evaluating it as a log in the slide before. That's it.